JavaScript can be confusing, right? The this keyword, prototypes, callback functions, scope and hoisting, and a couple of other things, especially if you're new to JavaScript, but even as a bit of a more experienced developer, these things can be tricky. Now in this video, as well as in an article below the video and a course which you can optionally take, I compiled these different strange aspects to hopefully make them a bit less strange. Scope and hoisting are key concepts of JavaScript, and this snippet shows us both in action. Now what's scope? Scope is all about the visibility of variables, so where in your code you can use which variable. For example, that we can access the result variable here inside of this function, but also here outside of the function is possible because we declare and define it here in line 1. And therefore this function uses the so-called global scope. Actually, since it's created with let, it technically uses block scope, but this all sits in one big block of code. And in JavaScript, scopes work such that the variables defined in a scope can be used anywhere in that scope, but also in any child, in any nested scope. Now it turns out functions create their own scope. If you create variables in there with the var keyword, those variables have function scope, or if you create variables with let or const in there, those variables or constants have block scope, because functions, just like if statements and for loops, create new blocks of code. So a variable defined in a higher level scope can be used in a nested scope. So global scope can be used inside of this function or block scope. It would not work the other way around. If I have a new result here, where I use basically the other result, I could not use new result anywhere here, no matter where I try to use it. This would not work because this is now a constant created in this block of code, and therefore it's only available in there or in any other nested scope. That's what scope is about in the end, and knowing it is very important because it explains why you can access certain variables in some parts of your code and why you can't in others. Now another important concept in JavaScript, which also can be tricky to wrap your head around, is the concept of hoisting. Hoisting is in the end just a core mechanism built into JavaScript or into JavaScript engines that run your code that in the end enables JavaScript to be aware of certain variables and functions before the code execution reaches the function or variable declaration. Okay, that's a very technical term. What does it mean? Well, we see it here. We're calling add1 in line 3, but keep in mind that we actually only declare and define this function here in lines 6 to 9. Now, because of the hoisting mechanism, JavaScript essentially goes over your entire file before it starts executing it, and you could say it memorizes all those function declarations, so functions written like this. And that's why you're then able to call such a function when the code execution begins, before the code execution reached those lines down there. Important for hoisting is that it really only works in that way if you have a function declaration, so if you use this function declaration syntax. If instead we would have created a add1 constant and stored an anonymous function in there, and hence we would have used this function expression syntax, the add1 variable would kind of be hoisted, but you wouldn't be able to call it. So hoisting is really most important to be aware of or to utilize if you're using this syntax, because this then allows you to move functions to the end of your file, which can help you organize your code. Primitive values and reference values. That's a topic that's definitely confusing to a lot of developers. Numbers in JavaScript, as well as strings, booleans, undefined, symbol, and big int for big integer, are so-called primitive values. Any object in JavaScript is a reference value. And for that, it's important to keep in mind that arrays and functions are also objects in JavaScript. Now that's a nice differentiation, but what's the idea behind it? What does it mean? Primitive values, so numbers, strings, booleans, and so on, are immutable and shared by copy. Reference values are mutable and shared by, well, reference. But again, what does this mean? Here's an example. We have a number, 1, and I log number plus 2, and then I also change number here and store a new number in the number variable. Now, this is straightforward code, but it is important to realize and understand as a developer that behind the scenes, the value 1 here is actually never changed. When we add 2 to it, we're not changing the 1. The 1 always stays a 1. We of course do something else. We derive a brand new value, a 3 here, and we output this here. So neither the value stored in the variable is changed, nor the value itself behind the scenes in memory. It's always a 1, we just derive a new value here. And this is achieved by copying it by value. So what this means is that when we have a calculation where we use a value, that 1 is simply copied here, and we derive a brand new value. The same here. And when we then store this back in number, we're not changing the old value. The 1 still is a 1. We just don't need that 1 anymore. We copied it here so that we can derive a brand new value, the 4, but then the original 1 is simply dumped. We don't need it anymore. We got a brand new value of 4, and that 4 is stored here in number. Now that's just some theory, which is nice to know, but which doesn't really change how you write your code. You probably didn't expect anything else than what I explained here from this code anyways, right? Well, it gets more interesting when we talk about reference values, because that's the tricky part. As I said, any object in JavaScript is a reference value, and that includes arrays and functions. Now here we have a straightforward, simple object, an object with a age property which has a value of 31. Now the 31 of course is a primitive value, it's a number, but the overall object is a reference value. Now I create a new constant, me, and I save this object, which is stored in person, in me, because I point at person here. And then I change the person age, set it to 32, and I log me age. So I changed the age of person, not of me, but then I log me age. And if you would log this, you would see that indeed you get 32 as output, not 31, even though we never changed me.age. And the reason for that is that reference values in JavaScript are stored such that we have one object stored in memory, and what's stored in the constant here, or in the variable, doesn't matter, is a pointer at this object in memory. So the address of that object in memory, you could say, the reference to it, that's stored in a constant. And when we create a new constant here, we just copy that pointer and store it in a new constant as well. But if we then use that pointer to manipulate the value, we work on one and the same value in memory, because that value in memory was never copied or cloned or anything like that. It's one and the same object with one pointer, and just that pointer was copied. And that's why we manipulate the object stored in me when we assign a new age to the person object, because it's not two different objects, it's one object in memory. And that's also why we can manipulate a const. This is a const, so we can't change the value stored in there, right? Why can we then assign a new age? Well, because we're not assigning a new value to person with that, we're changing the value the pointer points at, but what's stored in this constant is not that object, but the pointer, and the pointer doesn't change. We wouldn't be allowed to assign a new value to person, let's say a new object. This would throw an error, because here we really would create a new object, a new pointer, and try to store that in person. But what we do here is perfectly fine, because we're just changing an existing object in memory. Now there are techniques how you can copy an object, so how you can not just copy the pointer but the full object, and I do dive into that in the resources below the video, but for now, that's what you need to know about primitives and reference values. Closures can be the cause of a lot of trouble if you don't know how they behave and what they are. Now in general, every function in JavaScript is, or to be precise, forms a closure. Now that doesn't help you too much, right? Now what's a closure? A function in JavaScript, as we have it here, simply closes over its environment when it's created. And that means one simple thing. It memorizes the variables it has access to when the code that creates it executes it. And the consequence simply is that if a function is called at a later point of time, like this anonymous function here, which we call only after 1.5 seconds, it still has access to this myName variable here, even though it's running in the future, so when the other code execution already finished. It still has access to myName because the environment of this function, when it was created, contained the myName variable. Because of that scope concept, we have access to the global myName variable here in this anonymous function. But closures can still be tricky. We have access to myName, so what would you expect as an output here if I load this page? Keep in mind that this runs after 1.5 seconds. Do you expect max here, which is the value we have when we call that function that sets the timer? Or do you expect Maximilian, which I change after calling this function that sets the timer? Well, it's Maximilian, and this might or might not be what you expected. Now, I think it would be reasonable if you expected max as an output instead of Maximilian. After all, when we set the timer, when we called greetMeWithDelay, the value was max. So if the function, this anonymous function in this case, closes over its environment, and in this environment myName is max at the point of time we create this function, why do we then output Maximilian when the function actually runs? Because, and that's important, functions, closures in JavaScript close over the variable names, you could say. They memorize the variable names, not the variable values. The value is only looked up when the function actually runs. So the value for myName is only looked up when this anonymous function is executed, which happens when the timer completed. And at that point of time, the value is Maximilian, because we immediately changed this after setting the timer. And that's the essence of closures in the end. Recursion is a concept that's not exclusive to JavaScript. Actually, a lot of concepts covered here are not necessarily exclusive to JavaScript, but recursion can simply be tricky because it can be difficult to wrap your head around it. And here's a simple example for it. Recursion is basically just a function calling itself, like we're doing it here. We're calling factorial from inside factorial. And yes, this is something you're allowed to do in JavaScript. Now, why might you want to do it? Simply because recursion sometimes allows you to write less code than you would have to write with a loop, or in some cases, like if you're traversing some tree structure, recursion might even be your only strategy of handling a certain situation, like in such a tree structure traversal situation where you don't know in advance how many iterations you might need because you have a nested object and you need to go through all levels of nesting, something like that. I covered that in my course. But even in this simple case, this can be shorter than the loop you would have to write otherwise. Now, a good recursive function in the end always has at least two components. A base case, which is basically your non-recursive exit condition, where you return a value where you don't call yourself, and a recursive step, which is essentially you calling yourself. If you only have recursive steps, so if you have no branch in the function where you don't call yourself, you of course create an infinite loop and you don't want that, and therefore you need some condition in every recursive function in the end that cancels the recursion and gets you out of it. Now, if I log this here, we therefore see the result 6. And if you want to look behind the scenes of recursion, you can do this as well with the developer tools, for example, by simply adding a breakpoint here in your recursive function. If I now reload, it stops here. And what you see here in the developer tools is the call stack. The call stack is a mechanism that's part of the JavaScript engine in the end, which manages running function executions. JavaScript is only capable of executing one function at a time, but it can, you could say, pause a function execution to wait for another function to finish. And you can see this here. If I continue here and I step into the next function execution, you now see on the call stack we have 2 factorial function executions going on. And the one with the blue arrow is the one we're currently in. And that's recursion in action. We got more and more ongoing factorial function executions, but only the top one is the one that's currently executing. And at some point, once we made it deep enough into all of that, We make it out of the recursion and go through that call stack from top to bottom to basically return the value of every nested function execution to the next one in line in the call stack until we're back to the main function execution, which then ultimately is able to complete and return us the value we're interested in. That's how recursion works under the hood, and that's how you can debug it and how you can hopefully avoid a lot of headaches related to that. Callbacks and related to that, direct versus indirect function execution can also be confusing to newcomers. Here is a classic scenario of regular direct function execution. We have a function, we then call it. And you call a function when you basically add parentheses after the function name, after having the function defined, of course. This then executes this function right away and runs whichever code is in it. Now here's an example for indirect function execution where we utilize a callback. We add a listener to a button here, and this addEventListener method does not only take the kind of event you want to listen to, but also the function that should be executed when the click occurs. And I often get asked why we don't have parentheses here. The reason is simple. If we would have parentheses here after addUser in line 9, we would immediately execute addUser when JavaScript reaches this line of code. Now it reaches this line of code not when a click occurs though, but when it simply adds the click listener. And that's of course not when you want to call this function. This should fire when the click occurs instead. So adding parentheses here is definitely wrong because that would always lead this function to be called when the listener is added, not when a click occurs. If you remove the parentheses, you pass something else to addEventListener. You pass the name of the function that should be executed eventually to that addEventListener method. You pass a pointer at this function object to addEventListener. And addEventListener internally then will use this argument and the value stored in it, so the function, and call it for you when the time is right. So in this case, when a click occurs. And that's what I would like to call indirect function execution, but this of course also is a concept which is simply called callbacks. We're using a callback function here. We're passing a function as an argument to another function so that that other function can eventually call us back and call this function for us when the time is right. And that's why we don't add parentheses here and how callback functions work in the end. Now, as with all the concepts below the video, you of course find a more detailed resource on that. This is just a brief summary, of course, because when it comes to, for example, pre-configuring parameters addUser should receive eventually, you need to use certain tools, like the bind method, which is in JavaScript, but again, that's covered in the additional resources. Now, we just saw callbacks in action. One area where callbacks are typically used is the area of asynchronous code. Now, JavaScript is single-threaded, which means it can only do one thing after another. And setting a timer and then executing another piece of code works, but maybe not in the way you would expect it to work. Because JavaScript, when you set a timer, does not pause code execution. It only has one thread available to perform tasks, to do work, and it does not pause when you're setting a timer or sending a HTTP request, because that would mean that your scripts are basically worthless. If they can only do one thing at a time, modern web applications, where a lot of things happen simultaneously, would just not be possible. Instead, JavaScript offloads certain tasks to the environment it runs in, like the browser. With setTimeout, which is a function made available by the browser in the end, it simply offloads the task of setting a timer to the browser, and the browser also, you could say, memorizes the function, the greet function here on the slide, that should eventually be called when the timer completed. So the browser manages the timer, and JavaScript can continue to do other things. It can run other code, synchronous code, so code which finishes instantly. And when the timer expired, when the time is up, the browser will notify JavaScript about this and tell it, hey, you gave me that greet function, please execute it now. And JavaScript will schedule this greet function to be executed as soon as possible, so as soon as it has no other work left to do on its single thread. That's how asynchronous code, so code that takes a bit longer, you could say, works in JavaScript. JavaScript performs task after task, so setting a timer and console logging, and this all happens basically instantly after another. It does not wait for 5 seconds here, instead it directly moves on to the next line and only executes say hello after 5 seconds because the timer is set and managed by the browser and it basically tells JavaScript when the time is up. That's how asynchronous code works. Now, callbacks are always important in asynchronous code, but for more complex asynchronous code structures or snippets, we also have the amazing feature of promises in modern JavaScript. Here's an example. The fetch API is an API built into the browser, and it sends a network request and gets some data. Now, when we get that response, we often want to parse the data that's in the response, and it turns out that in JavaScript, as this API is set up, this is another asynchronous task. So this JSON method, which basically parses the response data and gives us a JavaScript object, does not finish instantly. Now, if that fetch API, which is built into the browser, would use callbacks only and not this promise concept, this might look something like this. We have fetched, we have a function that's executed when that fetch process finished, when we got a response. In there we call JSON, and to JSON we pass another function which is executed once the data has been parsed. And if we do more and more asynchronous work, we have a deeper and deeper nesting. That's called callback hell because it can quickly get quite hard to read. Now, promises work differently. A promise is simply a JavaScript object that has a then and a catch method. And fetch returns such a promise. We can basically call the then method to set up a function that should be triggered, that should be executed when the promise resolves. So when it's done with its work. Now, the trick is that every then method then by default returns a new promise, or if we return a separate promise as we do here, JSON also yields a promise, that default promise is replaced by that returned promise. So long story short, then always yields a promise object itself, which is why we can chain then calls. We can call then after then, because then yields a new promise. And this allows us to set up steps of code that execute after each other. First, we wait for the response, we start the data parsing process, and when that's finished, this code here, this function here, executes. And error handling is also easy. We can add a catch method in this chain here, because every promise does not just have then, but also catch. And catch will trigger this function when any prior promise fails. So this promise, or the main fetch promise. If any of those three promises fails, this function here will execute. That's how promises work, and of course there's a bit more to them. In my JavaScript The Complete Guide course, as well as in the JavaScript The Tricky Parts course, I dive a bit deeper into them. Here, the key takeaway is how asynchronous code generally works, that tasks are offloaded to the browser, and that we have callbacks and basically the enhanced version of callbacks, promises, to then orchestrate our code steps, our code snippets that should be executed when such tasks finish. Okay, you probably waited for it. One of the most tricky things in JavaScript is the this keyword. It can really behave strangely, and here's an example. When I call output info, I in the end call this printH method, because I store the printH method in output info in line 8. So we would expect to log the age of the person here, right? Because that's what I'm referring to in line 4, which is in that method that's being called. However, if I reload this in the browser, we see undefined instead of the age. And that simply happens because of the way that this keyword works. This, unlike in other programming languages, does not always refer to the object it's written in, you could say. Instead, this, and that's a good rule of thumb, refers to who called a function. If you're using this, it only matters about the function it's being used in and who called that function. And if we, for example, do person print age, you will see that we get this age output here. And the reason for that is that we call print age on person. So person called that function, you could say. And therefore this inside of print age refers to that. When we call output info like this, you could say no one called that function, or that function is called on nothing. And therefore this inside of the function refers to not nothing, but actually to the global window object. That is, you could say it's fallback if it's not called on anything else. And that really is the most important thing to memorize about this. When you think about what this refers to, you should look at the function that's being called and how it's being called. And if it's called on something, this will refer to that something. If it's called like this will not refer to the object it might be used in, but simply to something else, typically to the global window object. So looking at who called something and how it's called is the key to understanding this. Now, there still are some special cases, like having an anonymous function in an event listener, where this will not refer to the window object, but to the element that caused the event. But that's covered in the additional resources below the video if you want to dive into that. The key takeaway is that rule of thumb that you look at who called a function or on what a function is called, and that this then refers to that what. Now, the last tricky thing I want to dive in this video are prototypes. Prototypes are an essential part of JavaScript. They are the key concept when it comes to inheritance in JavaScript. And yet, prototypes can be hard to understand and to reason about. And the name is part of that. Prototype sounds like blueprint, at least to me. But a prototype in JavaScript is actually more of a fallback object. And that's the core idea of prototypes. Every object in JavaScript has a prototype. And you either get a default prototype if you create an object like this, then the default prototype is object.prototype, more on that in a second. Or you create an object, for example, like this, with the create method on the object constructor function, and you can set the prototype of the to-be-created object to some other object. In this case, user has person as a prototype. And the consequence is that if we access a property on user, which doesn't exist directly on user, JavaScript has a look at its prototype. And the prototype of user, which is person, does have that kind property. And that's really the essence of prototypes. Prototypes are fallback objects in JavaScript. You can set them when you create an object like this. You can change them after an object has been created with set prototype off, for example. And you can also set them on constructor functions. Here we have the person constructor function, and there we have that special prototype property, which is often misunderstood. Using that prototype property, which exists on every function object in JavaScript, does not set the prototype of this person constructor function object. Instead, we set the prototype of to-be-created objects that are created based on this constructor function. So by executing the constructor function with the new keyword. So Max here has human as a prototype, as a fallback object, because the constructor function is pre-configured to give it that prototype. That's what the prototype property does. If you want to find out which prototype an object has, you can use the __proto___ property. This is a non-standard property, which means it's not part of the JavaScript standard, but most browsers support it, and this gives you the prototype of an object. It's nice for analyzing your code, it's nice during development, but otherwise not a property you should really use. Instead, this prototype property allows you to pre-configure prototypes on constructor functions, and you got the other methods you saw before for setting and changing prototypes. In addition, in modern JavaScript, you also got the class keyword and the extends keyword to extend another class, so to have inheritance. And under the hood, this also uses prototypes, but I dive deeper into that in my Tricky Parts course. The essence of prototypes is that they're fallback objects JavaScript uses to look up missing functionalities. And if you wonder why we have that, let's have a look at an array. 1, 2, 3, a simple array of numbers. Now that's a straightforward array, and if I log it, it's not too exciting what we see here. But we actually see something interesting if we take a closer look. This array object arrays are objects after all, has 3 keys, 0, 1, 2, and 1 extra key, the length key. Okay, that's all nice. That's what is created when you create an array. What you don't see in this object, however, are all those array methods like push or map or filter. And you of course know that those methods exist on arrays. Now, they're not part of every array object because that would take up a lot of space in memory. If you work with a lot of arrays in your code and every array has all those methods, no matter if you use them on this array or not, that's a lot of extra stuff to store and to manage, and that's not great for memory and for performance. Therefore, instead, a newly created array has a special prototype, a special fallback object, which then has all those methods. So which has push and pop and all those array methods. And every array has that same prototype object. So that utility object with all those methods is only created once, it's only stored in memory once, and then every array is just linked to it through that prototype concept. And that's why we have prototypes. It makes managing code easier and allows us to, for example, optimize memory and performance.